China just built a 90-story skyscraper with almost no human workers. You heard that right. A building as tall as 27 Statues of Liberty stacked on top of each other, constructed almost entirely by robots. But this wasn't some distant sci-fi fantasy or theoretical experiment. It happened. And right now, while you're reading this, more of these robotic construction sites are rising across China, completing in months what used to take years. The question isn't whether robots can build our future, they already are. The real question is, how are they doing it? What machines made this possible, and what does it mean for the rest of us? The construction crisis and the robotic solution. You're standing on a construction site in Shanghai, and something feels profoundly wrong. It's too quiet. There are no jackhammers screaming, no workers shouting over machinery, no chaos. Instead, you see machines moving with deliberate, calculated precision, and almost nobody here to operate them. This isn't an accident. This is the answer to a crisis that's been building for decades. Traditional construction has always been a numbers game, and the numbers don't work anymore. In China, you need to build faster, much faster. The urbanization happening right now is unprecedented in human history. Millions of people are moving to cities every single year, and they all need somewhere to live, somewhere to work, somewhere to exist. But here's the problem. Building skyscrapers the old way takes time. It takes armies of workers. It takes constant supervision. It takes risk, and the risk is staggering. Construction is one of the deadliest industries on the planet. Workers fall from heights. They're crushed by materials. They're exposed to toxic chemicals day after day. In China alone, thousands of construction workers die or are seriously injured every single year. You heard that right, thousands. That's roughly one worker every 2 hours. These are real people with families, with dreams, with futures that get erased by a single accident that could have been prevented. But it's not just about safety. It's about exhaustion. Human workers can only do so much before they break down. They need rest. They need sleep. They need time with their families. A construction crew working on a massive high-rise project might complete 1 or 2 floors per month. That timeline stretches across years. Years of payroll, years of coordination, years of complications. Then there's the labor shortage. China's population is aging. Young people are moving away from dangerous construction work towards safer, more prestigious careers. The workers who built China's economic miracle are retiring, and there aren't enough young people willing to replace them. The skilled trades are becoming a ghost profession. Companies desperately need workers, but the workers simply don't exist in the numbers they need. This is where everything changes. A few visionary companies looked at this crisis and asked a radical question. What if we didn't need human workers at all? What if we could deploy intelligent machines that could work 24 hours a day, 7 days a week, without getting tired, without getting hurt, without asking for a paycheck? Bright Dream Robotics and Legend Robot didn't just ask the question. They answered it. They built machines specifically designed to handle every single labor-intensive task that slows down construction. They created robots that could plaster walls, level floors, lay bricks, paint interiors, and pour concrete with a precision that humans could never achieve. And they didn't stop there. They built an entire ecosystem of specialized robots, each one designed to handle one critical task better than any human ever could. This wasn't theoretical. This wasn't a prototype sitting in a lab somewhere. This was real technology, deployed on actual construction sites, right now, building the skyline of tomorrow. But here's where it gets truly remarkable. Bright Dream Robotics. The wall plastering robot. Imagine you're inside a massive concrete shell. Bare walls stretch before you, floor after floor, rising into darkness. In a traditional construction project, this is where armies of plasterers would arrive. They'd spend weeks, sometimes months, applying plaster by hand to every single interior wall. It's backbreaking work. The compound is heavy, your arms ache, your shoulders burn. You're working at height on scaffolding that sways when the wind picks up. One mistake, one moment of lost focus, and you could fall 30, 40, 50 stories. Now imagine something different. Imagine a machine rolling into that space. The Bright Dream Robotics wall plastering robot is unlike anything you've ever seen. It's sophisticated without being flashy. It's methodical. It's relentless. The robot approaches a wall and stops. Sensors scan the surface. Computer vision systems analyze every centimeter, looking for imperfections, variations, anything that could affect the application. The robot's cameras are seeing in ways that human eyes simply cannot. They're picking up microscopic details that matter for the final product. Then, without hesitation, the robot begins. The plastering arm extends. A fine mist of compound starts flowing with absolute precision. There's no wavering. There's no inconsistency. The robot moves methodically across the wall, applying exactly the right amount of plaster at exactly the right thickness. You watch as it covers an entire wall in a fraction of the time it would take a human crew. But here's what truly matters. The quality is flawless. Every section matches perfectly. The thickness is uniform. The surface is smooth. When you run your hand across it, you feel perfection. Millimeter-level precision, repeated thousands of times, never varying, never faltering. One robot, multiple floors, working without breaks, without mistakes, without safety concerns. In a 90-story building, this single machine can complete interior wall preparation in a fraction of the time it would take 50 plasterers working around the clock. But this robot never needs to sleep. It never gets sick. It never decides to quit. It just works, day after day, floor after floor. And with each floor it completes, the project accelerates further ahead of schedule. The speed is transformative, but the precision is what actually matters. And it's about to get even more remarkable. Bright Dream Robotics, the floor-leveling robot. You move to the next stage of construction, and you immediately see the problem that most people never think about. Concrete floors aren't perfectly level. They're close, but not close enough. Tiny variations a millimeter here, 2 millimeters there, add up across the massive span of a floor. What seems insignificant in isolation becomes a catastrophic problem when you're building upward. Uneven floors throw off everything that comes next. Walls won't be plumb. Doors won't hang right. The entire structure becomes compromised. This is where the floor-leveling robot enters the story. The machine is essentially a grinding and measurement system combined into one intelligent unit. It rolls onto the concrete surface, and immediately, something extraordinary happens. Laser scanning technology activates. LIDAR sensors begin mapping the entire floor in three-dimensional space. Not approximately, not roughly, with absolute precision. Every high spot, every low spot. The complete topology of the surface gets recorded and analyzed in real time. The robot's AI system processes this data instantly. It calculates exactly where material needs to be removed, exactly how much, exactly which sequence makes sense for efficiency. Then it begins grinding. The abrading head descends, and the robot starts its methodical work. But here's what separates this from any human-operated grinding machine. The robot never deviates. It never gets tired. It never loses focus. The pressure remains constant. The speed remains consistent. The depth remains exact. You could position 5 human workers with grinding equipment on this floor, and they might finish it in a week. They'd probably do decent work. But they'd also have variations. One worker might press harder than another. Someone might get tired and lose precision. Inconsistencies would creep in. The floor-leveling robot? It completes the same work in 48 hours with zero variation. Every millimeter of the floor ends up within tolerance, perfect, usable, ready for the next phase. But the robot isn't done. As it works, it's continuously rescanning. The LIDAR is constantly updating its three-dimensional map. If something unexpected appears, a protrusion, an irregularity, the robot's AI instantly recalculates and adjusts. It's not following a pre-programmed path. It's making intelligent decisions in real time, based on what it's actually encountering. This is the moment when you realize something fundamental. These aren't just machines following instructions. They're intelligent systems making decisions autonomously. The floor-leveling robot completes one level and moves to the next. On a 90-story building, that means it's going to level 90 floors, without human intervention, without fatigue, without error. The quality of every single floor is identical because the machine is incapable of inconsistency. You step onto one of the completed floors and run your hand across the surface. It's perfectly smooth, perfectly level, This is precision that transforms what comes next. And what comes next is about to get even more dramatic. Bright Dream Robotics. The bricklaying robot. Now you're watching something that feels almost impossible. The bricklaying robot stands before a wall that needs to be built, and you realize you're about to witness one of the oldest human trades become obsolete in real time. For thousands of years, bricklaying has been a core human skill. It requires precision. It requires understanding. It requires feeling the mortar, sensing when it's right, positioning the brick with just the right pressure. Entire civilizations have been built by bricklayers who developed this intuitive mastery over decades. And now, a machine is about to do it better. The robot's vision system scans the wall layout. It knows exactly where each brick needs to go. It has the architectural specifications loaded into its system through building information. Modeling data every brick placement mapped out digitally before the first brick ever touches mortar. The robot doesn't interpret this data the way a human would. It doesn't make judgment calls. It executes with absolute fidelity. The robotic arm moves with purpose. It picks up a brick. The grip pressure is calibrated perfectly, firm enough not to drop it, gentle enough not to crack it. The robot positions the brick in three-dimensional space with millimeter accuracy. It applies the mortar in the exact quantity needed. It seats the brick with consistent pressure. Then it moves to the next position and repeats. What takes a skilled human bricklayer 30 seconds per brick takes this robot 15 seconds. The quality is superior. The consistency is absolute. There are no crooked bricks, no uneven mortar joints, no weak spots from incorrect seating. The wall that emerges is structurally perfect and aesthetically flawless. But here's what truly matters. The robot never tires. A human bricklayer can work productively for maybe 8 hours a day. After that, fatigue sets in. Quality degrades. Mistakes increase. The robot works 24 hours a day, 7 days a week, maintaining identical quality throughout. It never has an off day. It never makes a careless error. You're watching walls rise at a pace that would be impossible with human labor. Interior walls that would take a crew weeks to build are completed in days. Structural integrity is guaranteed because every brick is positioned exactly where the engineers specified it should be. There's no guesswork. There's no human error. There's only precision. The tension builds as you realize the implications. An entire profession is being fundamentally transformed. And the transformation is far from complete. Bright Dream Robotics, the interior painting robot. You climb higher into the structure, and now you're seeing spaces that are starting to feel like actual buildings. Walls are in place, floors are level. The skeleton of the 90-story building is rising before you, but the interior is still raw, unpainted, unfinished. This is where the interior painting robot becomes critical. Painting might sound simple. It's not. Interior painting on a massive high-rise is one of the most labor-intensive, tedious tasks in construction. Workers have to access every wall, every ceiling, every corner. They have to maintain consistent pressure on spray equipment. They have to ensure even coverage across massive surfaces. They have to work at height on platforms and scaffolding. They have to do this for months. It's monotonous. It's physically demanding. It's dangerous. The interior painting robot eliminates all of this in one stroke. The robot rolls into a space and immediately scans it with laser precision. Its computer vision system maps the geometry of the room. It identifies every surface that needs paint. It calculates the optimal spray pattern. It determines the exact amount of paint needed to achieve consistent coverage without waste. Then, it begins. The robotic arm extends. The spray nozzle activates. Paint flows in a precisely controlled pattern. The robot moves methodically across every wall, every ceiling, every corner. The spray pattern is absolutely consistent. The pressure is identical on every pass. The coverage is uniform across every surface. You watch it work and realize something stunning. It's completing in hours what would take human painters days or weeks. But more importantly, the quality is superior. There are no drips, no uneven coverage, no areas where the painter's arm got tired and the application became inconsistent. The finish is flawless. The robot moves from one room to the next, then to the next floor, then to the next level of the building. It's working its way through 30, 40, 50 floors, leaving perfectly painted surfaces in its wake. No fatigue, no variation, no mistakes. But what makes this truly remarkable is the precision achieved through laser scanning. The robot knows exactly how much paint each surface needs. It doesn't over-apply, creating waste and mess. It doesn't under-apply, creating thin spots. It applies exactly the right amount, calculated by AI systems analyzing every centimeter of surface. The finished walls are ready for the next phase almost immediately. No touch-ups needed, no corrections required. Just perfection, repeated across an entire 90-story building. You're beginning to see a pattern now. Each robot completes its task flawlessly. Each one accelerates the overall project, and each one eliminates an entire category of human labor from the construction process. But Bright Dream Robotics isn't the only company transforming this landscape. Legend Robot, the finishing specialists, and the technology stack. You descend deeper into the construction site, and you encounter something that feels like stepping into the future. While Bright Dream Robotics has handled the structural and interior preparation, Legend Robot has been developing an entirely different class of machines. These aren't just robots. They're specialized finishing systems designed to handle the most intricate, detail-oriented work that separates a building from a completed structure. The latex paint spraying robot stands before you first. At first glance, it looks similar to Bright Dream's interior painting robot, but it's fundamentally different. This machine is designed specifically for protective coatings, the high-performance finishes that protect buildings from weather, UV damage, and degradation. The precision required is even more demanding than standard painting. The coating thickness must be exact. The coverage must be absolute. One weak spot, one area of under-application, and the entire building becomes vulnerable to damage that could take years to become visible. The robot deploys laser scanning to measure every surface in 3 dimensions. It analyzes the data and calculates the precise spray pattern needed. Then it applies the latex coating with millimeter-level accuracy. The thickness is uniform. The coverage is complete. The finish is flawless. A job that would take human painters weeks happens in days, and the quality is demonstrably superior. Next is the putty spraying robot. This machine handles wall preparation for final finishing. It scans walls to identify every imperfection, every dent, every irregularity, every surface variation that could affect the final aesthetic. Then it applies putty with surgical precision, filling exactly what needs to be filled, no more, no less. Computer vision verifies the application in real time, making adjustments on the fly. The result is walls that are perfectly smooth and ready for final finishing. What would require a skilled tradesperson weeks to complete happens in days with zero waste and perfect consistency. The tile-laying robot enters the scene next, and you realize you're watching something that seems almost impossible. Tiling is one of the most demanding finishes in construction. Each tile must be positioned with millimeter accuracy. Grout lines must be perfectly aligned. The surface must be perfectly level. One misaligned tile throws off everything adjacent to it. A human tiler might complete 5 or 10 square meters in a day, working with intense focus. The tile-laying robot completes 50 square meters with perfect alignment on every single tile. Computer vision verifies placement continuously. Laser scanning ensures the grout lines are perfectly straight. The aesthetic result is flawless, and the structural integrity is guaranteed. The floor-grinding robot appears next, preparing concrete surfaces for final coatings. It's grinding away imperfections, creating a perfectly smooth substrate that's ready for sealers and protective finishes. The laser scanning continuously maps the surface. The AI calculates pressure and speed, and the robot maintains perfect consistency across vast floor areas. Then comes the high-reach autonomous finishing robot, extending its manipulators to reach heights that would require dangerous scaffolding with human workers. It applies final touches, finishing details, and protective coatings in spaces too elevated and precarious for humans to safely access. But here's what ties all of these machines together: the technology stack underlying every single robot. Computer vision systems give these machines their eyes. Cameras constantly feed information about the environment, about surfaces, about obstacles. Real-time image processing analyzes what the robot is seeing and makes split-second adjustments to maintain perfect execution. The vision systems aren't just seeing, they're understanding what they see. Laser scanning and LIDAR create three-dimensional maps with incredible precision. These sensors measure distances with millimeter accuracy, creating a complete digital model of every space the robot enters. The robot uses this data to navigate autonomously, understanding exactly where obstacles are, exactly where surfaces are, exactly what needs to be done. AI navigation systems process all this information and make intelligent decisions in real time. The robots aren't following pre-programmed paths that might fail if something unexpected appears. They're making autonomous decisions about how to proceed, how to adjust, how to overcome challenges. Machine learning means they improve with experience. Building information modeling data serves as the digital blueprint. Every robot receives the architectural specifications before it even arrives at the site. It knows exactly what needs to be done on every floor, in every room. The robots don't interpret the plans. They execute them with absolute fidelity. All of this culminates in millimeter-level precision, cascading through the entire construction process. Each robot delivers perfect output that sets up the next robot for perfect execution. The entire system operates as one coordinated ecosystem, with machines communicating, coordinating, and executing in perfect synchronization. You're no longer watching isolated machines. You're witnessing an integrated intelligent system building a 90-story structure with a level of precision that would be impossible with human labor. And the results are becoming impossible to ignore. The 90-story project in action, and the future is here. You step back from the construction site and try to process what you've witnessed. A 90-story building, taller than most of the world's tallest structures, is rising before you at a pace that defies conventional understanding. What should have taken 5, 6, 7 years is happening in 18 months. You heard that right, 18 months for a structure that would traditionally consume nearly a decade of constant human labor. The robots are working 24 hours a day, 7 days a week. While human construction crews are sleeping, the machines are advancing. While humans are resting on weekends, the robots are progressing. The floor-leveling robot finishes one level at night, and by morning, the bricklaying robot begins the next phase. The painting robots complete interior work while the finishing specialists move to other sections. There's no downtime, there's no fatigue, there's only relentless, methodical progress. Multiple robots work simultaneously on different floors. The concrete pouring robot operates on the lower levels, while the wall plastering robot works mid-rise. The tile-laying robot handles bathroom and kitchen finishing, while the high-reach autonomous finishing robot accesses dangerous upper sections. Each machine operates independently, yet in perfect coordination. They communicate through networked systems, sharing information about progress, scheduling, and emerging challenges. It's a symphony of mechanized construction, where every instrument knows exactly when to play. The speed is transformative, but safety is the true revelation. Human workers are conspicuously absent from high-risk zones. Nobody is climbing scaffolding at 300 feet. Nobody is spray painting in confined spaces where toxic fumes accumulate. Nobody is working at heights where a single mistake means falling 90 stories. The robots handle every dangerous task. The few human workers on site supervise, monitor quality, and coordinate logistics. They're not taking risks, they're managing systems. Construction site safety metrics have improved dramatically because the most dangerous tasks are no longer performed by humans. The workforce transformation is undeniable. What would have required 500 construction workers now requires 50. Those 50 people aren't laboring in dangerous conditions. They're operating technology, they're managing processes, they're ensuring quality control. It's a fundamental shift from labor-intensive to technology-intensive construction. But this isn't just happening in Shanghai, it's spreading. Other cities are deploying similar robotic ecosystems. Other companies are developing competing technologies. The robotic construction site is transitioning from experimental to standard. Within 5 years, building without autonomous robots will seem outdated, inefficient, dangerous. The economic implications are staggering. Construction costs plummet as automation scales. Projects complete faster, reducing financing costs and economic uncertainty. Affordable housing becomes possible through sheer efficiency. The speed of urban development accelerates globally, but the labor market transforms too. Construction workers are displaced, but new roles emerge in robotics operation, maintenance, and system management. You're not watching a distant future, you're witnessing the present. Right now, while you're standing here, robots are building the skyline of tomorrow. The 90-story building before you isn't an anomaly. It's proof of concept. It's the blueprint for how cities will be constructed from this moment forward. The age of robotic construction isn't coming.